the line y equals x plus 3.25 is tangent to the graph of the function f of x equals 3x squared minus 2x plus 4. Right, so we have a quadratic, a parabola, if we were to graph it, and there's a line that is tangent to it with a positive gradient, right, a gradient of 1, and it is tangent at this point, 0.5, 3.75. Cool. So if this problem scares you a little bit, I would recommend graphing it. So first of all, you would graph 3x squared minus 2x plus 4, and then you would graph x plus 3.25. And you'll see that their intersection point is this coordinate. Cool. But the question is asking us to use calculus to show that this line is a tangent to the curve and to find that intersection point. Alright, so for a line to be tangent to a curve, what that means is the gradient of that straight line is the same as the gradient of the function at the point where it intersects. So if you zoomed into this parabola, right at that point, it will have a gradient equal to 1, right? Because the tangent line has a gradient of 1. Right, because y equals mx plus c, so the m in front of x, the gradient, in this example is 1. So let's show that the line is tangent to the curve. To do so, we will find the gradient function, f prime of x. To do so, we take the power, multiply it out the front, so 2 times 3 gives 6. And then x to the power of 1, as we subtract 1 off the power. Minus 2x, the derivative of that becomes minus 2, and the derivative of plus 4 becomes 0. Now, we know the gradient must be equal to 1, right, from the tangent line. So we can set the gradient, so f prime of x, as 1, and then solve for x. So I'll add 2 to both sides, divide both sides by 6, and we get x equals 3 over 6, or 0.5, which does confirm that it will intersect at that x value. Awesome, so we're halfway there. Now to find the y value, we will substitute the x value into the original function. You could also substitute it into the tangent line, right? 0.5 plus 3.25 does give 3.75, so that would work too. So let's use the original function. A little bit harder, but that's fine. So when we substitute 0.5 in for x, we get 0.5 squared, so that's a half squared, so that's a quarter, so we get 3/4, minus half, 2 times a half, which is 1, plus 4, which is, that's 3, plus 3/4, so that's 3.75, which is what we expected. So we can conclude, therefore, the tangent line y equals x plus 3.25 is tangent to the original function f of x at that specified point. Awesome. So just to recap that question, it was a verifying that a straight line is tangent to a given function, our step 1 was to find the derivative, so f prime of x. We then use that and the fact that the gradient must equal 1, and we solved for the x coordinate of the intersection point. And if you got that far, you would get achieved for this question. The last step was to then use that x value in either the tangent line or the original function, right, to find the y value of the intersection point. So we did that here. And always best practice, do write a short conclusion if it's like a show that question. So we found the y value and we wrote a short conclusion, would give us merit.